So hello everyone. So do you have any clarification regarding the exam, that is regarding the minor exam? Do you need any information? Because sometimes I got mails from students, they ask some syllabus or type of question. So do you have any? So if you have any clarification, you can ask regarding the minor. Yes, no, nothing. Okay, but still, I don't know. Many people ask actually. So what is my plan? So exam will be around 1.5 hours, I think, around 90 minutes. Okay, so I am planning to giving 6 questions. So 3 from logic, okay, 1 from relation. That relation topic, that doesn't mean that I'm asking it is a relation or months that equivalence relation or not. That's relation chapter. That is the first two lecture, first yeah, 2 lectures on relation, right? We have sixth and seventh lecture. One on countability, one on cardinality. So this is my roughly plan. So these 3 questions will have 3 different types, obviously. Okay, so this is just a roughly plan of this one, and question paper will be of 35 marks. So 90 minutes, 6 question, 35 marks, 3 questions on logics, one on from relation, one from countability, one from cardinality. So that's it. And the question type, some of the questions we have seen that similar type of questions during uh, yeah, in the course and in the from the tutorial as well. So I'm not giving that any question from the tutorial, but there will be some types will be there. And also we discuss some problem, and there will be some types of problem as well. So this is the plan for your minor. And remember that so for this you should check your grade scope. Because question paper will be given in the Gradescope only. So you have to log in Gradescope and you need to find the question paper from there. And then after the exam, that is after 90 minutes, you will get additional maybe 15 to 20 minutes time to scan and upload your answer sheet on Gradescope. And also you have to map properly. So you have to upload in Gradescope only and map properly. I know you, I think you know, right? How to map in a Gradescope because you have given exams in your previous, maybe in yeah, even in the calculus course as well. So you know that how to map in Gradescope. So you have to map properly. Otherwise, you may get 0 from on this question if you could not map properly. Because when we will check question, so it will come. So suppose we will check that question number 1, and all the answers it will be come together. So if you do not map properly, then you will we will see a different solution and you will get 0.
What is the timing of the exam?
Yeah, timing I think it is 9 to 10:30. I have given, right? I have given the one mail. So you have not received my email?
We have received the mail.
Yeah, that was the timing, that 9 to 10:30. That is that 90 minutes. And remember that you have to join before 9. So that's when you have to join at least 8:55, because we need some time to show that your location is fine or not, or your that environment is suitable or not. So you have to join a little bit early, and you are not allowed to join after 9. And again, remember that I am very serious about that cheating part. So if you copy from order, even if you share your question paper, answer sheet, and someone copy from you, so if we see that there is a matching answer, then we will give 0, not only on that particular question, you will get 0 in your minor. And you cannot appear for the re minor as well for that one. So you will get 0 out of 35, and it will be a huge loss. Then you will never get B grade, never get A minus, never get A. So you have to satisfy at most B minus, that is 7. Okay, so you have to be careful about that cheating. So you cannot copy. So you cannot copy from others, even you cannot share your answer sheet. You cannot say that, okay, I share my answer sheet, but I did not copy. That will not work. So if we see any matching answer, whatever you are, you will get 0. Either you share or you copy, that does not matter, you will get 0. You will get 0 in minor. In out of 35, you will get 0. That's all.
So
Okay.
is 35 will grade down to 30?
Sorry?
Is 35 marks will grade down to 30 marks or it is 35 marks?
No, it is 35. We are planning to have that is 35 and then quiz on 15. And maybe if quiz is 20, then we will reduce the marks in major. So because when we are writing that question and writing that answer question paper, then we feel that okay, that we have 6 question and 5 marks for each question is little bit less. So we think we have to give 6 marks. So therefore it comes down to 35. So 35, whatever mark that will be there only. We will adjust in major. If it is 35 and 15, then 50 marks, then in the major that there will be 50 marks. So 35 means 35. So we will not reduce later. Okay. And 1.5, yeah, 90 minutes for 35 marks, it is fine. Within 30 minutes, you have to answer 6 questions. That is fine. For each question, you will getting 15 minutes. So that is fine. Okay, so do you need any other clarification? You can ask. No, I don't know. You people not asking when we meet live, but you generally ask through email and you ask through WhatsApp sometimes. Who have my WhatsApp number? Sometimes you ask TA during tutorial, but you do not ask me. Why? You should ask, right? You did not ask what do you mean by cardinality, and I have to um, watch the tutorial videos to know that okay, you have doubt that what is the cardinality, how to write a cardinality of a set, is it countable or uncountable? Then I told you that no, when we ask cardinality, then write it is LF naught or LF1 or LF2 what, because by the cardinality of uncountable set we generally or infinite set we generally mean the stages of infinity, right? So you have to write either it is LF naught or LF1. Also we
Sir,
have, yeah,
but in the
yes.
question, the tutorial question, it was given, it means they were proving like countable and uncountable, but only that.
Which one?
So the first part, I think, the first part of the question. No, the second question of the last tube, where we
No, no,
have
no.
to
Sure.
comment on.
When we ask the cardinality, that's when you have to show that what is the cardinality. It does not mean that it is countable or uncountable. You have to show it is LF not. I mean, if it is countable, right? LF not. If it has the countability that cardinality same as R, you have to write it is LF1 like that only.
So, but in that solution, it was just countable and uncountable. It means they just proved that it is countable and this is uncountable only.
Right. But see, in the question paper also I have written that. So I asked that cardinality means you have to write in terms of LF naught or LF1 or LF2. Hi Deepak Kumar. So here, what is the uploading time? So basically the uploading time is 15 minutes. So I think that is fine. So you can easily scan and upload within 15 minutes because now you are familiar with that. For the first year student, they need around 20-25 minutes, but now 15 minutes is sufficient for you. So we will not give more time because sometimes what people do, they scan and then they circulate that. And then the other people get time to copy. So therefore we will stick to it that 15 minutes. And remember that we will not collect any answer sheet on um, right. We will not collect any answer sheet through email. So you have to upload on Gradescope only. Okay. So now I think I can start the
But to show it is if not we can directly show na it is countable.
ellipse knot. Right. It is countable. For ellipse knot, you have to show that it is countable. And for LF1, you have to show it is count. See, this means this type of symbol it is like in. I can write in, but it is not in. It is ellipse knot. That's been countable. And this means cardinality same as R, right? And this has cardinality same as power set of R, and so on. Okay, so you have to just find what is the cardinality.
Sir,
Hmm.
so one doubt, like is it true that the cardinality of a countable set and this Cartesian product, finite Cartesian product, the countability is same. I'm sorry, the cardinality is same.
I did not get your question. So finite number of
No, sir. Finite Cartesian product of a countable set and the only countable set. Are the
huh,
cardinality of these two are equal?
right. We have proved that, right? Yeah, in the class we proved that. If you have finite number of countable set and if you take the Cartesian product, then it is countable. We proved that. It is in the
It is sir, it is countable. Yes, sir, that isn't proof, but how to prove that they have same cardinality?
they are countable means they have same cardinality. So suppose A is countable, B is countable. That's mean both have bijective with n. So that's mean they have also bijective function, right?
So, okay.
What do you mean that A and B are countable? So A is countable, B is countable. That's mean there is a
If
bijective map F, there is a bijective map G. Then you can have a bijective map from A to B. It is uh, G compose F inverse. That's all.
sir, they will have same cardinality if they are infinite countable.
Huh, right. Ah, right. Sorry. Yeah. So countably infinite. Countably infinite. Otherwise, one can have finite and another can have countably infinite, but they do not have same cardinality. Yeah, thank you for the clarification. So if A and B both are countably infinite, then they have same cardinality. But if A is countable and B is countable, that does not mean that they have the same cardinality. Okay, because it can be finite, it can be finite, it can be infinite. Okay, so if you see that both are infinite, then you can see that they have the same cardinality. So generally, that portion of cardinality we generally say for that comparison comes for the infinite only. Because for the finite case, obviously you know which is a distinct number. So there is nothing to show actually.
Sir, you said that to prove the cardinality of set of real numbers and R cross R are same.
Huh.
Sir,
You
how to
can
prove that?
you can use that R and R cross R has same cardinality.
Sir, how to prove this?
You can use that fact. If we ask similar this kind of question in exam, you can use that fact.
So is there any way to prove it? Because since R is uncountable, so how to
Obviously, there is a way to prove it. So that was the reason I told you that
how
if you can watch that YouTube video as well, but you did not watch that. There we have some questions, this type of at the end.
so but I think in those videos there were a lot of questions in which video we have to search.
No, but I send you one link, right? So there you had.
In that link there were I think 4 to 5 lectures of
Right.
more than one
No,
and
not 5 lectures. Four. There are 4 lectures, and all the 4 lectures are covered in this. But that has some extra problem. So for an example, say, okay, that is a easy one. So if you take 0, 1 to 0, 1, okay, and to 0, 1, you can have a surjective function. How do you have a surjective function from this to this? Just take say 0 point a1, a2, a3, comma 0 point b1, b2, b3. If you have this, now you map this one to 0 point a1, b1, a2, b2, a3, b3 in this way. Then you can find that this is a surjective function. You can prove it is, I think, injective as well. If you remove that, if you consider only one type of, what do you say? Yeah, one type of representation, you can find it is bijective, I think, as well. But anyway, you don't need bijective, but you can see that it is surjective as well. And then you can always have a surjective function from this is surjective. And also you have a surjective function from 0, 1 to this. Okay, so this is surjective, this is surjective, right? How to find this? Just put x. Oh, sorry.
Sir, that is injective, I guess.
Right. But you don't need that one. What I want to do, should do the reverse one actually. So from 0, 1 to 0, 1 cross 0, 1. You can do the reverse one. That's mean 0 point a1, say a2, a3, a4, a5. This you can find this one to this way. So 0 point a1, a3, a5, 0 point the next one I think. B2, B4, B6 in this way. Yeah, in this way you can construct a surjective function. So I think you can get a bijective function in this way. So that is trivial actually. You just check whatever you can do. Okay, so this is just a trick. So you can do that. So and then you will get that cardinality of 0, 1 is same as cardinality of this. And this is same as cardinality of R. And this is same as cardinality of R cross R. This one. Okay, so is there any problem here? That is not a difficult one. Yes. Yeah, in this
Sir,
way you
in
will
the,
get
in the
injective function. Actually, you will get this is surjective one as well. Or you can define in this way as well. So in this way you can prove that the cardinality of this is bigger than cardinality of this. You can check why it is injective. I think it will be bijective as well. You note it is not only for surjective injective, it will be bijective as well. You can prove that this is bijective function. Because this way you can define and the inverse one you can define in this way. Okay. Now similar way you can actually prove that cardinality of R is same as cardinality of Rn. That's mean finite product of R. In this way you can prove that. See why I told you towards those YouTube videos. Actually, yeah, I prepared that one and I thought, okay, I will give you the recorded lectures, and then I feel that people don't like the recorded lectures, so I gave in the live. But when I record that lecture, that there are some few problems which I could able to complete during that 1 hour, or maybe one more than little bit 1 hour. But when I give live, then we were a little bit slow, right? So that's why we could not able to solve one or two problems. So therefore, those videos has some extra one or two problems. But otherwise, everything is same. Okay. But you can use that fact. If you can use this fact that cardinality of R is same as finite product of R. You can use that fact. And that is the idea. So how to prove? So from this 01 plus 01 to 01, you can get this map and you can prove that this is a bijective function.
sir,
Yes.
sir, in the last lecture, where we need to prove that closed interval 0 to 1 cardinality is equal to cardinality of R.
Closed interval 01. Yeah.
So, sir, we proved that cardinality of open interval 0 to 1 is equal to cardinality of R by a
Huh.
bijective function.
Huh.
And then, sir, we wrote like cardinality of open interval 0 to 1 is less than equal to cardinality of closed interval 0 to 1 and less than equal to cardinality of R. So how this
Huh.
the second inequality come? I mean the cardinality of closed interval 0, comma 1 is
So
less
this is
than.
fine, right? This is fine.
Achha, this is subset of this one.
Huh. And again 01, this is less than equal to this. So this is comes by that subset. This is comes by subset. And this is comes by the bijective map. So we have cardinality of R is same as cardinality of 01. Right? Okay, so I think now we can go further. So we can start that permutation combination, or maybe we can say that it is combinatorics. Okay, since I'm starting computers, maybe we split this lecture. Oops.